Today, we will be discussing shift-reduce parsing. This is a bottom-up approach that serves as a foundational technique in compiler design. Let us begin by developing an understanding of shift-reduce parsing and its core functions within the compilation process. There are several core principles to this method. It is built upon a lexical analysis foundation, where tokens generated by the analysis are crucial for parsing to commence, ensuring the input conforms to grammar rules. As a bottom-up parsing technique, it constructs a parse tree by starting with the input string and iteratively reducing it to the start symbol. The process is driven by two primary actions: shifting input symbols onto a stack and then reducing them according to defined grammar rules. This is why it is termed leaf-to-root construction, as it builds the tree from the terminal symbols or leaves towards the non-terminal start symbol, which is the root. Several key components are involved in these operations. The input buffer holds the sequence of tokens that have not yet been processed. The stack temporarily stores grammar symbols and reduced non-terminals, reflecting the current parsing state. An optional parsing table can be used to guide the parser's decisions, specifying which action, either shift or reduce, should be performed next. At each step, the parser executes one of four basic actions to dictate the flow: shift, reduce, accept, or error. We will now examine these actions in greater detail and review a practical application of the process. The process utilizes four fundamental parsing actions. A shift action moves the next available input symbol from the buffer onto the top of the stack. In contrast, a reduce action replaces a sequence of grammar symbols on the stack with a corresponding non-terminal symbol, following a specific grammar rule. An accept action signals the successful completion of parsing when the stack contains only the start symbol and the entire input has been consumed. Finally, an error action indicates a syntax error has occurred, which happens when no valid shift, reduce, or accept action can be performed. Let's review a step-by-step parsing example. The initial configuration begins with an empty stack and the entire input string, ID plus ID $, in the input buffer. First, the parser shifts terminals, moving ID from the input to the stack, followed by the plus symbol, and then the next ID. A first reduction then occurs. The ID on the stack is reduced to the non-terminal E using the grammar rule E derives from ID. Next, the parser handles the operator and second terminal by shifting the plus sign and the subsequent ID to the stack. A second reduction follows, where this ID is also reduced to E, which results in E plus E on the stack. The process concludes with a final reduction, where the sequence E plus E is reduced to a single E according to the grammar rule E derives from E plus E. In summary, shift-reduce parsing represents a robust technique for grammar validation, highlighting its significance in compiler design.